Okay, good evening, everybody. Welcome to the IAAC lecture series. Welcome to our houses as during all the lectures in the last weeks. We are virtually connected with our students. We are virtually connected with our faculty, our collaborators, and all the rest of the world. And it's a pleasure today to have with us and welcome in our lecture series Manja van de Worp. Manja is a very good friend on the one hand. She's a close collaborator at IAAC. She's a structural engineer, but she's a structural engineer with a lot of knowledge in architecture, in design, of course, and materials and digital fabrication and manufacturing. So she is the expert engineer where you go with a very complex problem of our creative and research minds, and she will be the one that makes sure that it's buildable, which is also very fundamental. Manja is the director of NOUS Engineering in London. Now it is called YIP, is it? It is founded since 2013. Before founding her own company, Manja has been collaborating with Arup in London, on the one hand in the Advanced Geometry unit, and of course at the Advanced Technology and Research group, where she has participated in a lot of different projects in terms of nature and scale. Manja is also a faculty at IAAC. She's leading a seminar on experimental structures, as well as collaborating with different prototypes that we are building, including a very challenging house in Nepal last year. And she's also teaching at the AEA and the RCA in London. She's actually now connected from London, and she will go through her work explaining a lot of research, but also applied research and projects that include structural analysis, complex structural systems, as well as materials and fabrication. And Manja decided for this lecture to celebrate the horizontal world, to celebrate collaboration. So during her work, she's not only going to introduce her projects, but she will also introducing during the talk a series of 3 secret and special guests that they will join her during the talk to discuss and collaborate some of the projects that she has been participating in. So we are looking forward to a very vivid and dynamic talk, a celebration of collaboration. Manja, with no more to add, I just want to thank you for being part of our team and also for joining us for this lecture. And if there was a digital clapping, now everybody would be clapping. So thank you, Manja, and the virtual stage is yours.
Hey, hi everyone. Areti, thanks so much for a cool introduction. And it's also very nice because then everyone indeed kind of understands a bit better of what is going on this evening. I will tell you guys a bit more about that as well. Indeed, I'm going to celebrate collaboration because otherwise I'm always talking. And as most of you know, I can also talk for ever about everything. And I thought actually it's nice to take the opportunity to indeed invite some special guests and also showcase kind of the importance of collaboration and working with different kind of people to create these kind of exciting indeed projects that I've been involved in. I'm going to share now my screen and that's it. And F5, it should work. And then here we go. Yeah, so I chose pink for the evening, one of my favorite colors. So I thought like, so today is going to be special because obviously it's the first time I'm talking for IAAC. So I wanted to do something that really involves IAAC, me, and the 3 dots, which are these 3 special guests. So, and together with that, I want to talk about this horizontal world, right? So what really is this horizontal kind of world? So this is a cool kind of picture of a think tank that I've organized. You will see some kind of familiar faces in that. It has professionals, students, architects, engineers, makers. And I want to really talk about the importance to learn from others and to bring different people together and talk about this collective and collective knowledge. What I'm going to do as well, I'm going to put my timer because otherwise it might last a bit too long. So I'm giving myself 12 minutes for this introduction. And yeah, most of you know as well that I miss timer. So now here we go to myself as well. So this kind of horizontal kind of learning strategies, find it super fascinating because vertical learning, as it says here, experiences are cases where a learner makes a lot of incremental progress on a scale from low to high skills, as if moving up a ladder, right? So that is kind of the typical learning. You learn a skill, then you improve it, you go to the next phase and the next phase, etc. But then horizontal learning, yeah, is a bit more like Mario Brothers. You have like ladders, let's say, that go up and down, and you need to actually use all of them and kind of still keep looking sideways. So horizontal learning is much more about kind of exploring and what these kind of ladders look like and where they can bring you. So horizontal experiences look a little bit like mucking around, and I will show some stuff of that as well. But really, they are ways of getting your feet wet, getting used to the water, and getting ready eventually to jump in and go swimming. And I really like this kind of idea of thinking. And I also think that is how I work and collaborate, hopefully with everyone around me. So let's see what the collaborators, the secret guests, will have to say to that in a bit. So a bit more to me, very super simple. Yes, I do structural design, geometry and fabrication, and that has been my passion. Yeah, actually since being studying in Eindhoven in the Netherlands, and where I'm graduated as an architect and an engineer. But then I also love making and breaking. I like to share crazy ideas and collaborate. And I also like to define a new lightness, which I've called Rubens. And I always challenge optimization. Then indeed, I teach or have taught now at AA and Bartlett. And at the moment I am teaching at RCA, where I lead the technical studies department for the MA architecture program. And of course at IAAC. Yeah, indeed, a bit of history. So yes, I used to work for Arup, which was the best breeding school to work with crazy architects, like really do experimental projects. I worked in AGU, Advanced Geometry Unit, and the ATNR, Advanced Technology and Research Department. And then indeed set up NOUS Engineering London, which is now called YIP. So YIP pretty much stands for yes, it's possible, which is my ultimate attitude to treat all projects. So what is the plan for today? So these are the images as well that I shared. And these are kind of small snapshots on the stuff that we are going to look at today with these three special guests. But before, I want to introduce a little bit more about what I was thinking about for today, because indeed, when Areti was saying, yeah, this is Zoom, we can talk with some cool people, like obviously here you see that now we could have like all of these amazing kind of architects that we can discuss with that are from all over the world. So I was thinking, okay, who shall I actually invite? So obviously, maybe some of you recognize here Gilles Retzin, who I also collaborate with. And this is a kind of fun image of one of our Zoom calls because we are working on 2 projects together again at the moment. But that is a bit too close to home. So, or maybe I should invite my all-time hero, which is Matsuru Sasaki, and actually really discuss optimization. So here you see one of his most famous books, Flux Structures, and that was really essential for me to kind of learn about in my education and in my kind of understanding of how we can actually play with structural design. And obviously I'm quite famous, or better notorious, in the aspect of optimization and my special ideas towards that. But no, not Matsuru Sasaki. Then I thought, okay, why not maybe put someone more local? So this is an image of the Cyclopean House by Ensemble Studio. is also one of my favorites, because I really appreciate, as you see here in the next image, that they really combine research and practice. And I think this is fantastic. I think that all of us should get our hands dirty and actually kind of experience at one-to-one scale, but also at prototyping scale, what it is that we are actually designing. And I'm sure that without having their kind of backyard and, you know, starting to prototype some of these big I-beams, which you see here on the screen themselves, yeah, they would have never just come up with that starting in Rhino. So I think that materials are really, really essential. But I even wanted to go a bit more local to me and IAAC. So I always forget how long it has been, 2013, my goodness. So for this evening, I have invited 3 special guests, my collaborators, to discuss some of our work. And in turn, we will reveal some of the insights to 3 projects, all of which have a very close link to IAAC. The original projects are funky in form, yet require no form of optimization. Well, maybe, let's see. Bring food for thought, for sure, and explore a new collective design methodology. So who are these 3 secret guests? And like, look, me, I'm always really kind of surprised by all of these logos we always see also in the Google Docs. Oh, Anonymous Wolverine is also here. Who is that, right? So you can dream a little bit more. So, again, I want to start with a little bit about my history and this kind of process from 2013 with me and IAAC, but more look at the kind of spin-offs of these collaborations and where they have brought me. So first of all, of course, with Areti, I always see her at conferences, workshops around the world, and of course at the best parties. But the start was our road trip in Palestine, where actually we were both invited to do a workshop in Tel Aviv. And we met together with Luis Fraguada. And so the first collaboration kind of started also here to actually work with BAD. So we were working together with Ali on this kind of pedestrian bridge that you see here, which is this big circle. So I actually, by mistake, called it a collaboration, but that was already really cool collaboration, obviously. And here you see kind of some of the things we were looking at. So obviously, like in my work, I use a lot of structural analysis, but it's important to kind of try to think about how structurally we can actually change potentially performance in an architectural way. So is it completely closed? Is it actually a shelter? Can it become a billboard? Where does like the eye line of the person sit, etc. So obviously, as you see, I do a lot of sketching in Bluebeam, which is just the most basic kind of PDF editor. But I think what is really nice is to kind of is to explore these kind of methods together. Then we have Aldo Solazzo, obviously also a very famous faculty of IAAC. So he was actually one student of mine in the course that I'm teaching still at IAAC. And we did this Unfold workshop where we worked with folding in Milan, and you see here this kind of crazy folded stalactites hanging. But I think what was really important is that, you know, we brought together my knowledge, let's say, about Caramba, and Aldo and Efilena's knowledge about using Kangaroo, and we brought our knowledge together. So this is also really nice when you collaborate and share these aspects together. So this folding, I think, is really interesting because obviously it gives structural strength. So I wanted to show you this chair that I developed together with Michael Schöner, 2019, as it says here. And here, obviously, it's not because of their efficiency. Well, they are efficient because they are folded. But what has been really interesting is to try to see how we could work with both developable surfaces and how the kind of matching, overlapping, and creating the different geometries of all these legs actually could make an ergonomic chair that would flex a little bit, so it would actually feel nice to sit on. And this is the chaiselong that goes with this. So here, for example, we have the 5 o'clock version, which I thought was nice to kind of show, because actually, like the same as with all the the pointers, let's say on the clock, we developed different kind of times and tested the different kind of orientations of the legs. And this is a buckling analysis that shows that. So it's annoying because it's Zoom thing that keeps kind of popping up. But I run my class, which is called Data Informed Structures. And I used to do this class with Alex de Boer before Raymond Kranmuller joined. And this is one of the first, well, actually it's the first project that actually was at one-to-one scale, which is called the Magic Carpet. So obviously here you see again the kind of theme of folding kind of coming back. But what was interesting here is it was not really about just folding. We actually used principles of not unfolding, where we geometrically locked all the elements together, but we were able in these connections here to actually have very simple kind of pins, right? So this was really great because together with the students, the same as what I do in my practice, is really always working between the digital and the physical. And actually here behind me, I have some small even models also of the previous chair that I showed you guys, because it's important to kind of feel and test those. So this kind of course has given me a lot of testing ground. And so one of my kind of favorite ones is this chair called a continuous line. What I asked the students was to think about different kind of positions of how to use it. And they actually created an overlay of performances. So again, instead of thinking about optimization for one specific point, they had to balance and challenge how the different positions would relate to kind of geometry and stiffness within this product. So continuing on from that, and here you see, so actually lots have kind of come from my relationship with IAAC, is I also helped Alex and Eduard to with the OTF to think about 3D printing from a structural point of view. And actually we looked at cracking, so the curvature of the print and the drying and the overlap and the cracking, as well as looking at how can you print and then kind of test the material when it's still in its wet condition versus in its dry condition. But obviously the main output is to see how we could kind of inform this kind of robotic toolpath, right? With the information we are getting. And again, I don't know anything about 3D printing. I maybe can kind of imagine what kind of material and structural principles are. And it's really about testing these different aspects together. I will close quickly. I don't actually know how many slides exactly, but we will get there. What is important about this kind of 3D printing is that actually then I continued with Rob Stewart-Smith, who is at the Autonomous Manufacturing Lab at UPenn, and actually tried to work with 3D printed concrete, right? And also what I think is important is not only the scale, but also not everything has to be kind of crazy funky. It's also about experimenting with the things that are not yet defined. So for example, we were saying, why does everything have to be printed? Can we just not kind of, make hollow sections? So this is actually a part of a cantilevering wall and a beam intersection that would then just be filled with concrete on site. So this is about if we print and cast horizontally and how we can actually combine different techniques together. So I'm always up for the challenge, but also really to extract and give knowledge and to further our knowledge through these collaborations. And of course, as Areti already mentioned, with Eduard and Raymond in Nepal, and of course with all the students that were doing Data Informed Structures course. So again, a bit of concrete, but actually the project itself is this 6.5 meter timber tower that we constructed. I mean, amazing. Also, again, what a fantastic learning experience. So this is called NEST. It is Nepal Eco-Social Tourism Project. And I think, again, collaboration also with client here, Anil, super important from Backstreet Academy. We need all the time people that are adventurous enough to bring their challenges, their desires or dreams into this world, and have us crazy designers and engineers giving a shot at it. So the most crazy of all was this kind of a crazy piece of glass, which in the end they kind of put on top here. Or maybe it's not that crazy, because actually another crazy thing is that I've been sometimes called the best dressed engineer. And actually by some of my collaborators that are also, so you see me here obviously in the foreground, maybe for the people that don't recognize me. But when I met Marco and Claudia, Claudia Pasquero, she was running the first term studio. They're from Ecologic Studio, also based here in London. And we're like, oh, you're an amazing looking engineer, when I was wearing this kind of blue leopard print kind of onesie to the Valdaura opening party. So obviously that also kind of created a connection. And sticking here with the theme of best dressed, what is quite cool is that when we work together here on the Centre Pompidou 3D printed piece, we can actually see that they are actually, here we are using hairpins. So the same hairpins that you would actually put in your hair, they are here 3D printed to make sure that they have a certain flex, because you know, obviously 3D printed material is super brittle. You cannot just bolt it together. Also one little push and it cracks. So what we did, because I think it was 3.5 meters or maybe even taller, but let's say roughly something like that, this structure, we wanted to have something that would actually be much more flexible to allow this. So here we go again with kind of continuing and experimenting with these exciting ideas. But as I said already, too much about me. So let's get some work, let's get some show on from my famous guest and really continue the celebration of collaboration. So the first person has called himself Lil G. He's notorious to me because he would be the first on a Saturday morning to be ready for a meeting, even if we all went out, and obviously it would be weekend. Here you see him sitting in his studio, and we have been working together on this project called Ruin Studio in Scotland, designed by Lily Jenks and Nat Dorrent. And this has been a quite long process from 2012 to 2016. So here you see Nat in the background and Lily in the foreground. And as a duo, they, well, actually I collaborated with them doing the style shop, but you see that they have this kind of really drive for kind of working with kind of amorphous, kind of different spaces. So obviously they wanted to create something that is a little bit out of the ordinary. And what we are going to discuss a little bit more on today is this inner tube. So we have the ruins here, which is the bottom layer. I'm not really sure if you can see my mouse. And then we have an external envelope, and internally we have this structure that is housing program inside, but also between the surface and the external part. So here you see one of the first renderings that they made of this. So this project started through the collaboration with NOUS Engineering. And so it came really because Matt's wife was a really good friend, or is a really good friend with Lily. And in this way we got this project. So obviously, even as engineers, yes, we use Rhino, as you know from me as well. But it's important to kind of think about how kind of waffling or whatever we are using actually relates to a kind of structural approach. And yeah, it looks pretty messy. Obviously, all the geometries are super messy because they have been created in whatever software. There's no kind of rules to it. So how can we go about this? And imagine 2012, right? So it's pretty long ago. So then also what is really good is actually, again, make these small models. And this is a prototype at 1:8. Well, why 1:8 is because actually the layering of the plywood would actually be perfectly scalable to the 1:1 scale. So that's why it's using 1:8. But you see here that we have a primary structure that is making the shell with this kind of timber ribs, and we have this grid inside of it. Here's some more kind of images of these. And so again, the main kind of internal structure and how they would be kind of created. So what was super important in terms of collaboration is that here, these two guys, well, actually shouldn't lie, not this guy, unfortunately, just this guy here in the blue. He would be the one, he's the son, and his dad that is not in the picture, are the ones that actually also to date have installed the real structure in Dumfries. So what was really interesting about this collaboration is we made a small model. They could really understand how it would work. And then we made another scale model that actually would allow the people that would construct it to kind of test it and to kind of learn how to put it together. But not only that, we made it very messy. So we tried to think, okay, on this kind of undefined geometry, like how can we actually create some kind of cladding on this? So here you see some of this experimentation. And one more aspect that is important to note is that in mid-2014, so imagine we are already 2 years in, we went from this, where we have the kind of continuous tube, to this, value engineering. So all of a sudden, we didn't have the full tube, we had to redefine the geometry, and all of a sudden, obviously, the kind of design had to change again. So here you see another image of that. And here you see it during construction. So you see the beautiful ruins and you see the external skin, and then internally will be the inner tube, as we called it. So this is what you see here. Obviously, we built first the external skin. And what we used was just polyurethane foam and glass fiber reinforced plastic. So here you see the architect, or one of the collaborators of the architects, Patty, and this is Nat. And here we have this kind of 3D printed kind of objects. And you might wonder, why are they 3D printed? And these are actually the contractors and the other guy that is here. Well, because where we constructed it was at MDM Props. So this is quite interesting because actually they made it super DIY style. So from a 3D printed, very scale model, they would actually make massive props like these. So they don't use any digital tools. They actually just do it through measuring. And these were the guys that also helped us to construct it. So here you see how it went from the small one into the kind of internal structure. So this is during construction, the image on the right-hand side. And you see the polyurethane foam, and you see as well the kind of meshes kind of turned over it, and the little kind of infill panels that we created to fit inside the timber structure. So the timber structure was more like a kind of placeholder that would then be kind of rigidified by this infill kind of pieces. And yes, so it used a hammer. So this is what you can see, hammer, sorry, like a saw, sorry, to cut and shape all of these beautiful curves here. And this is one more image from the inside, again, during construction, because here the fiberglass reinforced plastic had to be dried because obviously we didn't want to have any seams, and this is a heating gun changing it. So, but let's hear a little bit from Lil G about what his interests were within this project. So I want to welcome Lil G to the floor. I don't know how to do it, but I'm sure one person will be doing that right now, isn't it? I should stop sharing.
Perfect, you've done it.
And then Lil G, you can go. Hello?
Hi.
Hi.
So,
Hello there.
We worked on this project about 7 years ago, and it was in a very remote area. So we wanted to work on this prefabricated structure. The fun thing about this project was the internal solutions rather than the external. So as Manja explained, I had this external envelope which was traditional due to restraints of planning, and we had this fun sort of organic form inside. And as collaborators, basically we wanted to redesign this form and structure and surface so that we could design this all parametrically. so that we could create easy flow for construction. Yeah, as Manja was explaining, at first we were giving.
Hey, Lil G, just so you know, you're not sharing your screen yet, right?
I was meant to, yes.
Okay, so we didn't see anything at the moment. So you should share your screen. It is again at the bottom, the green tab that says share screen.
Yeah, there we go.
Okay, so maybe it would be good to just go flick through it quickly. It doesn't matter.
Yeah, so as in you didn't miss much. We're just explaining basically what you explained. But so as engineers, I'm going to start again. We're asked to create this continuous flow so that we could easily design different parametric forms for construction. At first, we were given these surfaces, which were NURB surfaces, which didn't allow much play for parametric design. So we had to redesign it using different forms of tools. We played with relaxers using Kangaroo, and also mesh relaxers, such as Weaverbird and so on. Obviously, this restricted in terms of the project in terms of space and design. So it was a reiterative process. And we found the easiest methodology was to work with this crude meshes and then sort of relax that. So the client would sort of design the space and we would reiterate. Once that was solved and we had these continuous surfaces, we could create these waffle structures algorithmically, and also sort of create points where structure was important. So, for example, on the left, you have an important node where all components were coming together and tying in everything. We would create quick prototypes and also do everything in modular systems, considering the remote location. So here's one of the prototypes that Manja was showing. And this was one of the ideas we had come up with, where basically the client liked this idea of sort of having this timber structure which would be cladded and sort of act as a skin. So we algorithmically designed these different phases of planar surfaces. So you'd have planar surface in the form of a polygon, and diamond shapes where we have basically simple curvature, and the double curvature where you have triangulation. However, obviously, then due to time restraints and economic reasons, we sort of would have to postpone this idea. So we went on with designing the structure and envelopes so that we all fused together. And these were the results. The waffles we designed were also integrated within the furniture and within, as well as the structure, which was cladded according to the design intent. So these are some images from different magazines. That's it. Thank you.
Amazing, Lil G. Woo! I will clap for you. I know everyone else is clapping as well. So, but I think we can do the shared clapping at the end. Thank you so much. I think it's really nice because you are highlighting specifically, let's say, also the kind of geometric kind of aspects, and how obviously kind of in that time, now we're like, yeah, we can just do that. But still, like the yeah doesn't really work when we are working at this scale, and also when we have to really see how we define, how we define the structures. I will continue with the next special guest and the next project. So I'm going to share again my screen, share, and I will use this button. So this person has asked to be called Elinge. So for a while, we lived so close together. So actually that is here, which is in Wilberforce Road in London, which is near Finsbury Park. I had to laugh because when I was looking for this, I just saw like that actually they just blanked out completely the building next to it, which is here. Obviously we are there with the red door, so this is a bit funny. But there's something very special about this man, because the first time for a meeting where Lil G was already ready on Saturday to keep going, Elinge said it's raining, so yeah, I decided to work from home. So obviously I will never forget that anymore, because obviously now in this period it's kind of normal to work from home, but obviously when you are collaborating and working together, it's essential to be in the same space. So using a lot of sketches, I really think this is really good. It's really good to communicate, to try to explain what will be happening, and definitely also when you're still trying to figure out stuff. So the project, the second project is going to be Condrick House, which is a house in Los Angeles and is designed by B+U, and we did this together in 2016. So we did this again together with NOUS, and I just wanted to say, hey, Matt, Liz, and Omar, maybe you guys are here as well. And what was really kind of interesting is that Matt had already been doing some sculptures with B+U, and then it was really about how can we transform. Oh, I'm trying to move to the next slide. Yeah, it's just very heavy, sorry. How can we actually kind of bring this kind of a super freeform style language to a bigger scale architecture? So in this case, we started working with the fabricator from day one, and we are using FRP, and we are working with a sandwich that has FRP, fiber reinforced plastic, is on the outside, and we have balsa core on the inside. So all of you must remember this little kind of airplane. So obviously balsa is super light. Also what is quite good is that it can be quite well easily bent. And then we have this kind of two layers of fiber reinforced plastics on the top. So what we had to do is then kind of transform this kind of layering that doesn't have an isotropic behavior, meaning that it has different properties in different directions. We had to try first to model the behavior of the material and to make sure that it is actually correct in relation to the actual behavior of the material, and then incorporate it into the design. I don't know, somehow it seems to be a little bit slow at the moment. And we use this famous software called Strand 7, which is amazing for laminated composite capabilities. But as you see here, it's quite funny because they're actually showcasing a violin. It's amazing for meshing, but it's absolute DOS, right? So for example, this is an interface on how you might be layering up. This is a graphical definition of a ply layup, right? So we had to also really get into how we could work, let's say, between a Rhino and GSA, like another kind of engineering software, together with this software that could in detail give us much more information about the fibers. So we are trying to kind of model and deal with all of these structures or geometries that we would get from the architect and model its behavior. So that is the other image that I showed, because I thought this is quite characteristics, because we had to test or wanted to test the relationship between curvature, structural behavior, and the orientation of the fiber layups of the FRP, how many we need, what would be the depth of it, etc. Right? Now we're like, yeah, we're just going to do some force flow analysis. But obviously, also changes in directions really have a big effect on how the structure would behave. And also you cannot do everything super bespoke. You still have to think about what is the fabrication process, which panels will be made, etc. So I just wanted us to be reminded of this lovely software that we are always using in my class, which is Caramba, which obviously can show the principal stress lines, as in this case, but also in some cases very hard to read, right? So it's really important to capture behavior. Trying to move to the next slide. So here you see some of our kind of tests of different kind of orientations, also of the timber main direction, etc. So we really tested all the kind of impacts of the kind of different layers and try to get a feel before saying, yes, we are doing the final analysis. Okay, I'm trying to continue again. And some more of these images here. Yes, we had to build meshes forever. So this is also something, obviously, from architects, we always get, you know, something again, like what Lil G was saying before, like something that maybe looks good, but we have to kind of redefine it and also build the kind of meshes so that we can actually analyze them. So here again, you see that we were working on the kind of density of the meshes, and yeah, it looks indeed still very DOS. So then we go back to the Rhino world. So we are using part of this FRP sandwich as a structure, and other parts are also still supported by some kind of minor steel elements, as you see in this image. And then you see another kind of diagram here. So we had to really think about the interaction between the steel and the FRP panels. So sometimes we would really use the folding to actually become a proper kind of structural edge. Where we could, we tried to use this, and then we had to also kind of see how that would then be connected to the actual steel members themselves. Okay. So this is what you see here. So obviously we had to think all the time about different scales, about how do we model the behavior of the fibers? How do we get it linked to the geometry and to the various kind of interactions with the steel frame? How does the steel frame actually, is it able to transfer loads to the shell? So I called it here 3D modular behavior. And this is one other render of the project, still not built, but who knows, it might happen. So let's hear from El Inge. So I am going to, I know you can still kind of, yeah, you see, well, actually I'm going to showcase this slide. Okay, so I'm going to show you this slide, because what I'm going to do is I'm going to share with you some audio, because unfortunately El Inge hasn't been able to join, so that will take kind of less than 5 minutes. I'm going to play it now.
Hello everyone. I have the privilege to work with Manja in the Michael Condrick project in 2016. This project marked a beginning and an end to my professional point of view. I am a civil engineer. Currently I work as an structural design. And this was just the beginning of what I wanted to do in my professional life. This project is as if a UFO landed on the middle of the Beverly Hills mountain, one of the most expensive places to build, and with really renowned people. It was Michael Condrick is the CFO of iTunes, the Apple company, and it was a really interesting project as we designed. I say as no engineering when I worked with Manja. We made the base of a lightweight steel structure with some small profiles, and it made me realize the importance of having a structural design program, but the importance of designing each one of the nuts, each one of the beams, each one of the elements in the whole structure to make it self-sufficient for itself, to make it more economical for the customer, to make it fast to build, and between all of that, the cover of the house, it's really strange. It has a lot of curves. We had to make a lot of research into the materiality of each one of the materials, the strength, the force, everything, because it was a kind of material that normally it's used in building boats. It's a really light material with a lot of stress. Takes the form really well. So what we had to do is to explode the whole mesh and analyze each one of the parts of the whole structure and how to attach it to the main steel structure, and how making the wind analysis, it wasn't that much of a weight analysis. Here the wind took a really important part of the analysis, as the form is completely different to what we're used to. And so we had to make some tests in different programs, and it was really interesting because this made me realize the detailing that I had to do and to use before achieving the best structure possible for my projects. Currently, this helped me because currently I make projects since the architectural design. I also do the structural design, and most of the times I also build them. So this project made me realize the complexity involved in the whole process, and how you need to realize, even if you're not the one who's building it or who made the architectural design or who is making the structural design, but you need to think about it, that someone needs to use your information to achieve that project to happen and to become alive. I think that is the magic of the projects that we were able to work with Manja during 2016.
Okay, I am going to finish with this.
Sorry everyone that I couldn't make it and I had to send a voice message. But here the situation in Mexico currently with the COVID, the government just gave us like a green light to continue with the construction and all of the architectural and engineering works. So I'm like crazy. I was planning to connect, but we just realized this today in the morning. And I had to make a lot of changes, and as the schedule here in Mexico, between you guys it's 7 or 8 hours earlier, it's the middle of my day. But I would love to be there. Thank you very much, and for sure always love to have anything to do with IAAC.
Okay, I will clap for Elinge. So thank you. And also, as you hear, like, yeah, he's mega busy and runs a construction and engineering company in Mexico. So it's very great news, actually, that they're back on the road with their projects, and also very nice to again hear like about people that have experience in construction and engineering, like how this kind of complexities and again this idea of multi-scale kind of behavior kind of affects the design. So we are going to continue with our last amazing secret guest, who has been asked to be called John Doe. He's always capturing hearts, and no view is too high. So I'm going to discuss two projects here. So one of them you see here, which is the result of this think tank. I started with this image where you saw all the people on a big line, where I told you they're students, engineers, fabricators, architects, and John Doe was also involved in that. And apologies, because every time I try to move to the next slide, it's very slow. So I am not sure. Ah, here we go. So this think tank is the result of us looking at timber construction, flexible timber construction. And this was in collaboration also with Casper X. You should definitely check him out. Doing a lot of projects with him as well. IGA Architects in Denmark. So, for example, we even asked the members to start looking at a kind of toy to kind of get inspired on what flexible timber construction means and how we can think about elements, components, parts, and what is actually the definition of flexibility? How flexible do we need something to be? So we decided that we want to look at the element, the surface, the loop, and the block kind of scale. So obviously the element, it's really about kind of connections, and the flexibility lies in kind of disassembly, surfaces, loops. So as you see here, so this surfaces is more like walls. Then we have loops that are this kind of rings, and we also looked at blocks. And it just is very slow, so I'm apologizing. I don't know what to do. Okay, so for example, some of the collaborators here are Matt Murphy, who I actually met at Shape to Fabrication, and he leads Maas Bespoke, which is a timber product development company and works for Bouwman Lyons, so Bouw Lyons architects. We had Tom Svilans, he's doing, or he finished actually his PhD at CETA, and he was really, he's very skilled at freeform timber construction. And then we had Cristina Gamboa, very close to you, because she's in Barcelona and she runs La Col, and they did this co-op structure in Sans. You should all go and visit it when lockdown is over. So I wanted here to highlight with these different colors that people have different skills, different backgrounds, and these were the ones that we put together. And actually also what was important about this curation, together with Casper X and John Doe, that we allowed everyone to play. It was not like, yeah, just make something. No, actually, let's try and see what we really can do. So be really free and use this environment to kind of create. Oh, here you see again a familiar face, Raymond. But I think here it's important that also to know that we had students and also again professional architects and engineers involved. And all the times the teams were made to cross-fertilize on their skills and experience. They came up with something quite cool, which is this kind of post-tensioning system. I'm sure that Joe will go a bit more into that as well. So I will just kind of continue here, more again of these models. So this kind of system of kind of cables was kind of post-tensioning all of these elements together. And that is what you see here. So obviously we test build it, which was part of it. And what was important is that we were immediately kind of just going to the one-to-one scale and using our specific kind of tools, as you see here, which is a rebar tie wire twister, in order to kind of post-tension the cables inside. So cheers to everyone. After lockdown, there will be a 2.0. So we will actually continue kind of with it. So here you see the construction that actually built and 2 students that are photographed in it. But so we actually disassembled it, use it again, but also IGA architects, and we worked together on this project, which is called Minka. We developed another more, let's say, less prototypical kind of system for housing. So how could all of this kind of work together? So maybe we kind of look here at the structures that have been on tour, because actually people have taken forward the project that we built. But what is important, I want to just quickly go back to Matt here, Matt Murphy from Maas Bespoke. So actually they're building this kind of cassettes. So obviously he's very acquainted with using the laser cutter, the CNC mill, and kind of building this kind of cassettes. And also together with John Doe, we then had the liberty to assist them from a structural point of view to make their product better and to understand some of these aspects. So again, what is important is to realize is that I know Matt Murphy, again, from Shape to Fabrication, and we helped him to develop and assess the kind of structural aspects of these cassettes. And here you see another image of that. And here some crazy Excel output of all the testing that we have done. So obviously this requires the help of a great collaborator. So let's hear from John Doe. I'm going to stop sharing and I give the word to you, John.
Good afternoon. So do you see my screen?
Yes.
Yes. So I'm gonna explain a little bit about the secondary project that Manja explained. That was about mass bespoke and how actually this kind of systems can inform the construction industry and how digital tools, and especially collaboration, as Manja stated, in all the levels, between digital to traditional making, can benefit the construction industry. So this project was a project that was developed actually to, as the name states, mass bespoke, how to actually customize mass production. So actually how with a simple system, let's say this cassette that has just a rectangular shape, we can build multiple type of buildings at multiple scales while keeping a lot of flexibility in the construction compared to the traditional like mass prefabricated building style. So in this case, to explain a little bit overall the project, they embed a lot of different tools. Like they have, since the beginning, they use simple tools. So actually people can start designing. Actually, they want to embed their users with using a SketchUp to actually design their houses kind of some way. And actually involved with automatic beam system and always thinking on the fabrication to reduce and cutting down time. And that's when actually we went, Manja and me, we went inside to actually how we can inform and optimize the system on the structural point of view. So one of the complex points of these systems, once that the base system is simple, is a box, is actually how this outperforms when it's assembled together. That behaves completely different. Like it's not just a simple Lego brick. You need to, there's a lot of wind forces, like structural loads, moving charges you need to think of. So actually, this is, for example, how collaboratively this project is built. Like you can see millions of tools that are just one related to each other. And in this case, we just went through the structural analysis ones. And actually, we just we assembled some parametric models to test out what actually could be the best perfect fitting. Let's see. The perfect fitting of the cassette, always thinking of economy, fabrication, and actually the most important point that was for us out, that was a structural point of view, and how actually the shape of the cassettes will inform the performance of the whole structure. So actually you can see that we assemble a whole system that we tested with your lovely class tool, that is Caramba. And we have later actually compared to like some professionally graded and certified programs like OSCs to actually test the validity of the working tool and to see if the system, the result that we're getting from one program and the parameterization would actually behave in the same way in the reality. So actually we run a lot of tests, and we lately embedded some machine learning to try to optimize the process and not to be like manually taking all the time the multiple combinations. To actually, now they actually build and they are already assembled some houses with it. And it's a system that behaves all with post-tension. And that's where actually the research and the think tank that we call End-State came through. This workshop, the think tank was thought initially as what can be built with for flexible housing topologies. And that could not be done, as Manja stated, with actually a lot of work. Actually, we spent a lot of days just brainstorming, thinking. One of your lovely professors here, thinking on how actually could be the shape to develop simple enough structures, systems that could allow multiple combinations and multiple combinatories of pieces to allow what? To actually, we finish with an alphabet of elements. And that alphabet of elements was combined together with a post-tensioning system that we kind of simplified to have a lot of fabrication and testing, because actually we spent half of the time prototyping and half of the time brainstorming. We just fabricated in just few shots. So actually we can build this kind of flexible housing topologies. Right now that we live in a society that everything is changing all the time and we don't have permanent, we are moving every time, different work, different jobs. So actually we can build a new housing topology or not a new housing topology. It's like how actually we can refurbish the housing topology to match our new needs. So in this case, for example, you can see that it's also kind of a cassette with another alphabet of shapes that was post-tensioning system. And the system was always thought about transportation, actually how we can recombine and move multiple combinatories of the elements. So for example, this is the first configuration that we assembled, and Greenside Farm. That, as you see, it was like small, we call it the Darcy's retreat, because it was one of the collaborators in the think tank, and she loved it and actually stayed there for a few hours, just chilling. And actually, we got lucky because we could assemble again the same amount of modules, exactly the same ones. We just packed them and sent them to a truck. We assembled again in the UK Timber Expo in Birmingham in 2019 to actually show the possibilities of this kind of timber structure systems. And even more, like the system could be packed, and actually it was really funny, just to give you some funny facts. We actually rolled the whole system down the hill to move it because it was a big housing dice. Also, we got even luckier because we could assemble at the U-Block Center in Denmark, and in that case, we went to another third iteration of the project, where actually we built another completely different geometry output just based on the same elements. And you may see some elements are a little bit wasted because just that happened with recycling the elements again and again. And the focus of this project, this research, was actually how the living changes, how the living spaces change, and how can architecture transform with those spaces, and what is the post-recognition of the design process to a rather a pre-rationalization of the design process, and of course the flexibility out of this process. So luckily we even got a fourth assembly state that was completely different. In that case, I don't have picture to show you, I'm really sorry. And I just want to be finally grateful to Manja to give us the opportunity to talk into this session.
I love it. I look so different. And obviously we're all very tired. Yes, let's smile a little bit. We all know the drill, right? So thank you so much, John Doe, for this. And I think it's really nice, again, that you highlight the kind of importance of fabrication and the kind of drivers that we are trying to test and establish here, right? So what is this kind of flexibility? Like how, like actually, for example, the kind of 3-point kind of corner pieces are a very different way of structurally cutting up kind of elements that we normally put as a beam and a column. So we really thought about a combination of change, structural elements, architectural elements, post-tensioning, etc. So I think it's very nice also, again, to show how the think tank, the last project, really links to the first one that you showed, which is the mass bespoke cassette structures. Okay, I will resume with, I think, 3 more slides for which I am going to go and share my screen once more. I'm going to share, and obviously my final duty is to reveal. Woo! So obviously we had these 3 people, and I'm sure that one person really understands already what this image is about. So of course, I mean, super massive thanks, right? And I think it has been really great to kind of hear from you guys, and also to just kind of go into this together and kind of be able to share our kind of joint kind of experience. So the first person I want to reveal is Lil G. And Lil G is Joe Galea. So maybe some of you remember him. He is actually an ex-student at IAAC, and he has now his own practice. He is a Fab Lab runner, and into showing the more conventional world what we can do with these amazing tools. So Joe, thank you so much. And as I already said as well before, so amazing, I think, because also you were there on this Saturday morning when we were all still covered in glitter from the night before to still get going with the course. And I think it's really good. And I think it was so special to kind of work together. So thank you for this collaboration. Woo! I'll just clap myself, and then I'm sure that we will just kind of open after. And the second person, this is a bit a bad photo, but I'm just, I only took the print screens. Alinge is Alejandro Martinez de Campo. So he did my course in 2016 and then worked with me also in London. So Joe worked with me in London. And Alejandro worked with me in London as well. And now he has also his own practice, and he has 7 engineers. I'm like, what? How is this possible? Because obviously before this, I had the idea, and then we haven't been in touch. So you can see ICO, Architectura, so you can kind of check it out, engineering and construction company that he runs. And he has been helping me on the contract house. And last but not least, our John Doe is Eduardo Chamorro Martin. I don't know, because also sometimes obviously it's quite, I recognize voices, and I don't know how this is for you. So a proud PhD starter, lab planner, and an amazing doer. And I want to thank you so much, because I really think that really, with all 3 of you, it has been magical to kind of build on what, as a kind of philosophy, we started at IAAC, and how this has brought us together. So thank you very much. And this is actually for later. So obviously, I will repeat this slide in a minute again. After this is party time. So this is a Zoom call where the password is spare. So you can just take a print screen now. After we have had our discussion and Q&A, we can join each other to have a beer at this kind of a link here. Again, the password is spare. So I'm going to stop sharing now. And thank you, guys.
Thank you, Manja. Thank you for a unique way of presenting part of your work, and thank you for literally celebrating collaboration. I can't believe that you're just finishing with a link for a Zoom party. I think that's fantastic. But yeah, I think indeed it has been a unique way of explaining part of your work. But also the importance of collaboration, especially when we are dealing today with the structural, the architectural, the fabricational part of our designs. No, it's now more than ever that we need to bring together a lot of knowledge. So an architect that has no knowledge on material science or material properties, that has no knowledge on computational design for structural analysis, or has no idea, let's say, of digital fabrication and digital manufacturing possibilities, is probably an architect or a designer that would not be able to take all the possibilities of creating something novel in the built environment. So I think that more than anything, what you're showing is that there is this merge of disciplines. I don't know if I should call you a structural engineer, an architect, a designer, or a fabricator. I think that the way that we're working and the way that you have manifested in your talk of work today is really blurring these limits and these contours of disciplines. So I think that was a fantastic way of promoting horizontal versus vertical laddering going up in terms of knowledge, but also in terms of experience. So thank you very much, Manja. I would like to open up the discussion now. Any questions, you can either write it to the chat, or you can directly join us, unmuting, switch on your camera and join our talk. By the way, it's great to see you, Joe, and Eduardo. I did realize it was you from the third second.
Yeah, that was easy.
And what about Alejandro? Because also when I hear you guys, like for me, it's like also obviously I hear it kind of immediately. It's so kind of profound. Yeah.
No, I didn't get Alejandro. I have to be honest for that.
Yes. But very nice.
Okay. Any questions or any points that anybody wants to discuss with this lovely company here?
Yeah, actually, I have a question. Like, do you hear me?
Yes.
So, yeah, thanks, Eduardo, for the lovely professor. Anyway, so I mean, I had the pleasure like to jump through some of the Super Mario levels together with Manja, and I enjoyed tremendously like your openness and your kind of approach towards collaboration and yeah, just making things in this amazing spirit. I was wondering, or maybe you can tell us, apart from this approach towards collaboration, do you see any kind of overarching topics maybe that you just realized now looking back, putting together a presentation like this, like things that kind of reappear in your work, like some topics that you know that are your that you feel very connected to, like on a more on the content level and on the, like, let's say, level of collaboration, like things that you're interested in, that you would decide, for example, if you do a project or not. Like, what are the things that attract you in a project, and that you just do like to do. Thank you.
Yeah, no, great, Raymond. And because I think like maybe there are 100 things, but one thing is really like the kind of one-to-one scale, and also to actually really do it, but also be really true about this is going to be a real project, so we cannot do everything we want, right? And I find this is for me the most exciting challenge actually there is, because we have so much kind of capabilities of coming up with kind of novel kind of ideas that you know, we can bring different people together. But then also I think it's kind of good to say, like, what I want to do is bring this kind of to the world, and I want to somehow use it as a step to go kind of further and deeper into it, right? So kind of no paper architecture, don't stay at the small scale, just build it. And so obviously with Joe, so with Lil G in the kind of ruined studio, like obviously you can say, yeah, that was just interior. Who cares? I've never seen anyone just cut it like that, putting it, testing stuff at one-to-one, building it in location A, driving it to another place. Right, and this is the reality, as Joe was mentioning, of the project. It is a kind of remote place, and we had facilities here. So I think this kind of always the link really to the reality to me is kind of amazing. Maybe we can ask also the two kind of collaborators to say something, what you guys think, like also when we, when you hear also the other people's work.
Yeah, as in, such a project can actually be quite overwhelming, especially when you just graduate and you would have spent 8 years studying and have no reality of the real world. So working with you sort of gave that confidence to that you can make anything really. So and the process is really fun actually. So you're doing and throwing, and then bit by bit you build something, you know. So I would say usually it's the client, it's the budget, and then it's the people joining the team, which makes a great project.
What do you think, Eduardo?
Oh, just the last sentence of Joe, like, is the people who that makes the project that makes you convinced to work it together, like something that's a must always. Of course, if the project is interesting, it's much better. But I think that, as you say, like just having just one point of view of any architectural project is not that challenging and doesn't allow you that much flexibility. So in the moment that Areti says that if you know a little bit of everything, or you know people that you can collaborate with, and that opens up so much more opportunities, because it's like the more you know, actually the more you can fly like higher, and that's could be done by your own capabilities, or just the capabilities of your collaborators and the people you know, and that's like actually produces much richer projects in all senses.
Go for it.
No, I just because we're talking about collaboration, but we're also talking about real projects, and what Manja was saying, no, the possibility that this could be something built, it makes a lot of difference, of course, and rather than staying in the digital or in the drawing. And I wanted to ask you, because like one of the biggest challenges when we're trying to create, you know, like bespoke, complex, or even mass customized, prefabricated pieces, most of the times we are always searching to you know, like test the limits of the material. We want to test the possibility to go as sustainable as possible, as easy to assembly or disassembly as possible. You know, like there are all these kind of different criteria that we are adding into our complexity on a project. And when it comes to the prototype of it, when it comes to do a one-to-one scale of it, sometimes, you know, like most of these fail, or they need a lot of testing to go back to design, to refine design, and then try to prototype and build again. So my question would be, whereas there is ever a project that gave you a big learning on how to treat a material, a fabrication technique, or a certain geometry, and how easy do you think that this process of requiring one-to-one scale mock-ups and prototypes, how easy it is, or how, let's say, feasible it is within a process of getting into the completion of a real scale project, such as housing, a building, a cultural center, something that goes beyond the pavilion, let's say?
Yeah, maybe because let's say with this project, it's called Okinaga Note, whatever. It is a seaweed sculpture. And that was maybe, it has a relationship to, let's say, the Condrick house, because it's super amorph and it has a structure inside. And maybe as Joe was saying, yes, I always think you can do everything. But maybe there I also learned, and that was on a kind of smaller scale, but still it had to be exhibited in a museum, that you don't want to do everything. It's better to do certain things and to try to find out what the real hierarchy, so where you want to put your efforts, because you cannot, it is really not good to spread yourself thin. And I think that, you know, also, yeah, kind of defining then what this hierarchy is quite difficult in teamwork. But I think it's really important, because otherwise you just end up indeed with scrambled eggs or something like that, right? It's kind of nice, but it is better to do, yeah, to put efforts, let's say, in one place. And maybe on the other side, I think I always learn so much because secretly I always push myself, and I go, but not until the edge. I just go slightly before the edge, which is already quite also kind of dangerous, but I don't go and sit there on the edge. There's no point. It's good to go too short to your limit, but don't go and like, well, yeah, let's try this, because I think because of fear, let's say, or also because of inability to actually collaborate or share or say something, yeah, that just doesn't make sense. So maybe that is some wise words from this lady as well, that just came from random kind of thoughts.
Sounds good. Sounds good. I'll pass the microphone to a terrace in Barcelona, yeah, where people are confined there and want to make a question. So Matilde, Alex.
Hi,
hello.
How are you? I'm happy to say I guessed 2 of the 3. So I also didn't guess Alejandro, but I did guess Joe and Eduardo. And I'm beginning to understand some questions that Joe sent me on WhatsApp earlier this week. My question was, I guess, when we talk about the world of research and the world of field technologies, particularly in architecture, there's a really big gap between what we do in research and what we manage to apply in the field. And clearly these three projects they show that you can to some extent bridge the gap. But I was wondering if or you know, how much in your practice do you manage to work with these kinds of projects where you take from research to field technologies, and you know, just to have a kind of idea. And Alex also had a question. I don't know if you want to ask straight away, and then Manja answers everything together.
Maybe they are linked. So thank you very much for your presentation and this celebration of smashing borders between different different disciplines. I come from a very crazy background of French architect and engineering fighting over 100 years. And seeing your joy and celebration of this collaboration instead of this fight has been a very beautiful moment. And my question would be like, what would be the next barrier to smash? What are the next disciplines you would like to collaborate, and where you would like to be like carried on the next challenge?
Okay, so just because Mathilde, you asked more about, let's say, kind of the relationship or the amount of research versus kind of practice.
Well, not necessarily the amount, but how much do you manage to translate what you develop in research into practice, I guess?
A lot, but mainly you can, but it's never halfway. So it is more like, you know, yes, we do it, versus, yeah, these are cool ideas, and actually we have tested it a bit, but then all of a sudden, one, there's no money, two, there's no time. The contractor says, yo, I already have the stones here, so we just do it like that. So I think that there's something that either then kind of completely removes it. But I think the cool thing is that to a certain phase, we always have it. And I think this is also about, let's say, ourselves proposing and promoting something that actually might seem a bit more complex, but obviously one of my aims is to really be more simple, actually, and to do something quite elegant and not go something just kind of crazy for the sake of it. I really kind of hate that, let's say. So I think that, yeah, that there's a lot of research which actually is kind of implemented. And also I say all the time, oh, I don't want to do any more kind of pavilions. But actually pavilions always allow you to learn a lot. But maybe what I do is like link kind of pavilions really to a potential or have a more strong relationship with what practice, let's say, can do. So I think that is exciting. And then Alex, yeah, I mean, that is a complicated question, right? And obviously it also kind of changes like on whatever moment of the day you're asking this. So where is this going? Actually, I want to say that, and maybe it sounds super boring, I hope it stays the same, where I don't know where it goes. Meaning that I really think that somehow this kind of artistic approach, which I take, allows me to find and bump into people without having a strong kind of tunnel vision. And I mean, that is quite difficult because sometimes you're worried about money, or I do too many projects at the same time thinking about what is happening in 2021. But I actually think that because of being open and kind of part of things, always things kind of emerge. And I also, yeah, yeah, I don't know. I think that's it, because I cannot say what the next thing is. But the most important is to keep doing, I think, because if that doesn't happen anymore, then I just change profession. That's it.
Cheers to that, Manja.
Well, beer soon also on this side.
Any more questions to Manja, Joe, Alejandro? Alejandro, no. Eduardo? Okay. So
maybe then I can say one more thing, because obviously
how much did you suffer working with Manja?
Surf?
Suffer.
Oh! Hey.
I mean, laughing crisis and smile like hicks. and how much muscles on your body is like starting to heat up.
Actually, my name comes, John Doe is how you call like the people that dies without ID in the States. And this is because you die working with Manja, but it's really lovely.
Look, I want to say to that, I think that is quite cool actually to end with this, because yes, I'm a kind of tough lady, right? And also most of you know that. It's because I'm ambitious and also because I want to be challenged. So that's why I challenge you, because obviously you do what you want others to do. And also I want to say that I found it really magical because yeah, that you know, three kind of guys from IAAC have really worked with me. I think it's really, yeah, it's really amazing. So cheers to all of you. I still have like also an empty kind of glass here, but yeah, fantastic. Thank you.
Thank you, Manja. Thank you, Joe and Eduardo. And thank you, Alejandro, remotely. You will see the recording of that. Thank you for this informal on the one hand, but also like deep presentation and conversation. We really enjoyed that. And everybody have a good evening. Thank you for joining us and looking forward to our next talk. And Manja wants to say something last.
Yeah, I need to, because yeah, I'm just going to, actually in the Zoom chat, I will just put there, whoever wants to have a beer, it will take me, let's say 10 minutes. But then I open the other Zoom call just to have a beer and not like leave like and disperse into kind of thin air. So I'm going to, because I don't know what happened to this presentation.
Sounds good. You can share your party link and beer link. And just to also remind to everybody that is following us that on Friday, on Thursday, we have another lecture from Topotech, and on Friday at 5, we have an open day, a virtual open day of IAAC, where we will be able to share with you our master programs, our educational activities, but also you will have the possibility to get to meet all the faculty and the coordinators that they are working within these programs. So yeah, thank you everybody. See you in a while for a beer with Manja, and see you on Thursday for our next lecture series.
Okay, great. Bye.
Thank you, Manja. Thank you, Joe. Thank you, Eduardo.
Bye.
Bye.
Thank you.
Bye. Is cool, hè? Okay.